Okay. Anything else? Anybody?
So t-test, you are referring to the using the C value, right, sir?
We can find the C value in both ways, right? We have to find.
But sir, just one question.
Mhm.
For week 11, there was only one open session, na? And in that, everything was not covered.
He's
So,
right, sir.
Yes, sir.
Everything was not covered.
Okay, okay. Basically, if you see, we have
because
The test
released.
was not covered. But I
only
mean,
the
partial discussion was there in.
only the only
Uh,
the theory was slightly covered, and
mhm.
rest was not covered, sir. Actually, na?
Actually, see, thing is that we have to cover till week 12 before that, right? Before the due date. First thing. Second thing, we have released one live session unit on the portal. We had sent the announcement for the same. Did you check?
Yes, sir. That old live sessions are
Mm-hmm.
available in the portal.
Okay. So basically, there are some 2 to 3 sessions related to week 11. Okay. Those are tagged one. Okay.
Where are they released? Sorry, can you repeat?
In the portal itself, right? We had sent an
Under
announcement.
the lectures.
And there is one section called, let me share my screen. Just wait for a minute. So you can see there is one section, right? This live session, right? So these are the tagged, like you can check week 11 open session. There are some 2 to 3 tagged week 11 open session. Okay. You can go through it meanwhile. Okay. Okay. So what are the topics has been discussed in the last lecture?
So as far as I know, the general theory of like hypothesis testing, the
Mhm.
normal general theory, like nothing specific was covered actually.
See, no example. As no, I won't say no example. Rather, instructor has covered Z test. I mean, but application of that test was not discussed. So one question or two questions, and then after you can carry on. It
Okay,
would
so
be.
mainly, okay, so I think in week 11 there are T test and all right. J test and T test already is there, right?
But examples were not discussed.
Yeah. What
We
I'm
were run
asking,
out of time.
yeah, yeah. What I'm asking, that J test concept, okay, at least concept has been discussed.
P value, P value were discussed. Mm,
P value discussed, right? Level of significance.
Yes, sir. Yes, sir.
yes, sir.
Level of
Yes.
significance alpha and beta are discussed.
Yes.
Yeah, these
Yes.
all things has been discussed, right? And
Right. Right.
information about the J test
Yeah, yeah. It also
Yes, sir.
discussed.
Done.
done. And what about T test?
No,
No,
no, no.
sir.
It not done.
Not yet.
Not T test. Okay, I think only J test is in the week 11, right? If I'm not wrong.
Yes, sir. Yes, sir.
Yes, sir.
In week
Okay, okay.
12,
So
T test, P test, and F test.
no, there is not any called P test. That's a P value actually.
Oh,
First of all,
yeah, yeah. P values.
okay. So T test, I think it's in week 11, if I'm not wrong. Sorry, week 12.
Yes, sir.
Okay. Okay, no problem. So you want to do me 1 or 2 questions related to J test, right?
Right, sir. Right.
Okay, 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 no problem. No problem. I will do some 1 or 2 questions related to J
Sir,
test, and then we'll move to the content of week 12. Will that be all right?
Right, sir. Right.
Sir, also, sir,
Yes, sir.
one question, sir.
Hmm.
Like for the last week, sir, is it safe to say that hypothesis testing is the more important topic?
Yeah, it's more important topic. Okay. So are you asking which point of view?
Yeah, from the from future also, and from the
From future, correct.
exam
So
point of
for,
view also.
yeah, let me clarify one thing. So in the end term, right? So there will be major portion from week 9 to 12. I mean, content will be 1 to 12, but major portion will be 9 to 12. I will share the weightage soon on the discourse and all. Okay. First thing. Second thing, see hypothesis testing and all. This is very, very important, and we can say it's the root of the statistics if you are going in real world. Okay, because there is any problem, any problem is there, right? Then suppose some there is a owner of a company, he is claiming something and you are an analyst, right? Then you might be interested whether his claim is right or not. Yes or no? Suppose I'm an owner of a company, I'm saying on an average production is something like that in my company. Then you felt, yeah, the claim of mine is very high. Then you will be interested to whether to test my the claim, right? To test the hypothesis. Okay. So as per the information, as per the data, I mean, we will use the different kind of test and all. Okay. So that's very important. In hypothesis testing, you must have yesterday actually. Okay. So okay, let me share my screen. I will start. I will
Sir,
take some questions. Yes.
sir, the deadlines for week 11 and 12 both are on 13th.
Both are on 30. Okay, okay. We'll check with the team tomorrow whether we can extend the week 12 or not. Okay. So
Yes, sir.
if you are able to extend, you will get the announcement for the same. Don't worry. Okay.
Okay, sir.
Yeah, yeah, sure.
Thank you, sir.
Yeah, yeah. Okay, so let me take one example. Okay, so I think jet test has been discussed in lecture.
11.7, sir.
11.7, right?
Yes, sir.
11.7. Yeah, okay. 11 till 11.6. It's the p value. Okay. Meanwhile, what is the p value? Anyone can tell me? I mean, what do you understand by the p value?
It is the least alpha value on which you can reject the hypothesis.
I can reject my hypothesis,
Hypothesis.
right? Accordingly, I can. I mean, basically, I can. I will take the decision as per my result, right?
Yes, sir.
Okay. Okay. So basically, see, thing is that, so suppose there is a scenario, okay, where you know the mean. Okay. Sorry, not know the mean. We have to test for the mean. Okay, but you know the variance. Okay. Then in that scenario, I will use. I mean, to test the mean. Okay, I will prefer the Z test. Okay, that is the case. Okay, so let me take the one example from the lecture itself. That will be okay for us. So let me share my screen. Is my screen visible to all of you?
Yes, sir.
Yes, sir.
Okay, so let's go with the very first example, and I will take another example as well. Okay. Now, if you see what is the information we have given, so if you see here, mu is unknown to us, right? I mean, question is a random variable x is following normal distribution, okay, with mean, mu, and variance is given to us as a 9. Okay, let me write down the information. So it's saying x is following normal distribution with mean, mu, and variance is 9. So what else? For n equal to 16 IID samples of x. Okay, I have some 16 sample of IID sample of this x. Okay, now the observed sample mean is 10.2. See, this IID samples we had, right? This 16 IID samples of x, right? Now, what is the question says? The observed mean is how much? Observed sample mean is 10.2. That means what? What is the given to us? What do you mean by this 10.2? How will you
X
represent?
bar simple mean.
Correct, correct, correct. Correct. See, please, I mean, feel free to save. Only then we will be able to know whether you are getting or not. Okay. So that means X bar is 10.2, right? So what is that? See, this X IIT simple samples means X1, X2 up to X16, right? We had some IIT samples from there, and we had the sample mean X bar as 10.2, right? Now, just write the step by step. So, what conclusion would you G test reach if the null hypothesis assume mu equal to 9.5? Alternative is mu is greater than 9.5 at a significance level of 0.05. What if null hypothesis assume 8.5? Okay, okay. We'll check either one. Okay. Now, so what is the null hypothesis? It's asking. Null hypothesis is, I'm saying mu is equal to 9.5, and against I will we have to check mu is greater than 9.5 right now. Okay, what will be your test? First of all, how will you define your test? Test means what? Okay, by seeing this
Right
hypothesis,
field.
right tail test is okay. This is the hypothesis. Okay, how will you define your test? What I mean, what statement or what should be your test?
The Z value.
No, Z value is the okay. Here we have to test for the mean. So that means I have to apply the Z test. That's okay. I'm asking, uh, how will you do your test? That's the me. That is the question. Are you getting my statement?
So the
Yeah,
claimed
yeah, correct,
mu
correct.
is
Mu is greater than 9.5. So okay. So suppose this information is given to you. My question is, how will you proceed? What will be your test? When you will reject? When will you accept? That is my question.
Okay, according to p value or z value? Z test.
According to the hypothesis, I'm not going to. Okay, so what is the hypothesis? Mu is greater than something, right?
yes, sir.
So my test will be like this. I will reject my H naught, or I will
If
reject my
mu is
hypothesis.
less than 9.5.
Not mu. Yeah. So see, the test will be only on your sample. So I will reject my H naught if my X bar will be greater than some C. Yes or no?
Oh yeah, sir. Yes, sir. You're saying.
That was my question actually. Are you getting? This will be
Yes,
my.
Okay, okay. Yeah, got it, sir. Got it, got it.
Sir, please explain. Please
Okay.
explain.
See, what is your hypothesis here? I mean, what is your alternate hypothesis? Mu is
Alternate hypothesis mu is greater than 9.5.
mu is greater than
okay.
9.5.
Then when you will reject your H naught? If sample mean this sample mean will be greater than some constant, not
Critical
constant.
value.
Basically, this is some critical value. C means
Yeah.
critical value. Yes or no?
Yes, sir.
Okay. Now, so for this, how will you proceed? First, find the proceed with the probability of type 1 error. That means alpha, right? How will you define alpha? Probability of rejecting H naught when H naught is true. That is something I'm defining alpha, right? See why I'm proceeding with alpha? Because in the question we have given alpha, right? And alpha is something level of significance. Based on this, I will decide my acceptance region and rejection region. Are you getting what I'm trying to say here, everybody?
Yes, sir. Yes, sir. Got it.
Okay. Basically, what's the importance of alpha? Let me draw a graph that will give you some sort of idea. Okay, let me draw a graph, then we'll proceed further. Okay. Uh, okay, for alpha, basically. So suppose I have two tail test. Okay, everyone is familiar. What is the two tail test and single tail test, right?
Yes, sir. Yes, sir. We're
So two
familiar.
tail test means I mean on both sides basically.
Either or both side. Yeah.
Correct.
Either or both
So
side.
suppose I'm see at the end we have to convert into standard normal variate, right? So suppose this is my bell-shaped curve. Okay, okay, just treat as a bell-shaped curve. Right? Not properly. Okay, just treat as a bell-shaped curve. Okay, I'm not able to draw properly here. Okay, so this is the z equal to 0 mean. Okay, suppose this g represents the standard normal variate. Okay, if it's two tail test, right? So that means suppose this is the z alpha. Okay, and this is the minus z alpha. Because I'm talking about two tail test. So this is your critical value, and this is the your I mean, it's called basically upper critical value. I'm writing CV for critical value. This is called the lower critical value. Okay. So basically, if my test will be lie here, right? So then I will reject in this the shaded region. Okay. So basically, this is the rejection region. This is called alpha by 2, and this is the alpha by 2. Okay. This is happening in two-tailed test, and this will be 1 minus alpha. This is your acceptance region. Okay. Are you getting? This is for two-tailed test. What about I mean, basically, if you see here, and what about right-tailed test?
The error are only one side, right?
Okay, right-tailed test means right-tailed test means when it will be. So this is your z equal to 0. So this is your will be your critical value. Okay, so this will be your rejection region, right? Rejection region. Okay, I mean basically probability that G will greater than Z alpha is nothing but alpha here. Yes or no? And in case of left tail test, so I mean it's in other way. Okay, so this will be your mean at 0, and this will be your minus Z alpha. So basically, this is something you can decide about your rejection region, and also this will be your rejection region. Means probability that G less than minus Z alpha will be alpha. Okay. Now, till this point, it's clear to everyone. This alpha and all. Okay. Okay. So let's proceed. So alpha is nothing but probability of rejecting H naught when H naught is true, right? So probability that I mean alpha is nothing but probability of rejecting H naught when H naught is true. Now, if you have x1, x2, x16, right, from IID x, where x was normally distributed what's mu and 9, right? Okay. Then okay, what was the my test? What was my test? First of all, H naught was mu is equal to 9.5. Okay, alternative hypothesis was mu was greater than 9.5. Okay, and my test was I will reject my H naught if x bar is greater than some c, right? If you see this is right tail test, then if your x bar is, I mean your sample mean is greater than some c, then I will reject H naught, right? Yes or no? Are you getting now from where? Am I audible, right? I'm not.
Yes, sir.
Okay,
Yes, sir,
so
you are.
I mean everyone is getting.
Yes, sir.
Okay, fine. So what about, okay, so then what will be the distribution of x bar? If x is normally distributed mu comma 9 or mu comma sigma square, then what will be the distribution of x bar?
9 by n.
Only 9 by n.
Mu 9 by n. Variance will be 9 by n.
Mu comma 9 divided by 16, right? Yeah, n is 16 here.
Yeah.
You know, right? This is something we had already done, right? X1, x2, xn are some IID x, right? And x is, let's say, is distributed normally mu comma sigma square. Then distribution of x bar will be normal mu comma sigma square by n, right? Yes or no? Why
Yes.
we are interested in? Because we have to convert in Z test at the end. So alpha is probability of alpha is defined as probability of rejecting H naught given that H naught is true. Now, when you will reject your H naught? When X bar is greater than C, right? X bar will be greater than C. Given that what is your H naught? Mu equal to 9.5. So far so good. Any doubt? See, I will reject my H naught when I have decided my test. I will reject my H naught when X bar is greater than C, right? So X bar greater than C given that H naught is means mu is equal to 9.5. Till this point it's clear? Yes, no, any doubt?
Yes, sir. Yes, sir. Clear.
Right? Okay, so what is the key thing? We have to convert into standard normal variate. Okay, so if your x bar is a normal distributed as normally distributed mu comma 9 by 16, how I can convert in standard normal variate? X bar minus, we have to subtract the mean and divide by standard deviation. So what will be this, what will be the standard deviation here? 3 by 4. Yes or no? Greater than c minus mu divided by 3 by 4, given that mu equal to 9.5. Yes or no?
Yes.
Till this point it's clear. Okay, what I will write this quantity?
Z.
I can write simply
Yes.
g, right? Now we know mu is equal to 9.5 here, right? So I can substitute at the place of mu, it's 9.5, right? 3 by 4. Till this point it's clear. And what is the alpha? Alpha is given to us 0.05. Okay, so basically it will be 0.05 equal to what I can write down now. I can simply write down. So since to convert in abject value, see, first thing is we have to convert in standard normal variable, then convert in CDF format. So to convert in CDF format, what we have to do, it should be less or equal to, right? So to convert in less or equal to, what I can do, 1 minus probability z less or equal to c minus 9.5 divided by 3 by 4. Yes or no? So next step will be, okay, what should I write now? Tell me.
fz of c minus 9.5 upon 3.5.
C minus 9.5 divided by 3 by 4.
3 by 4.
Right? Now, what will the next? So can I write fz of c minus 9.5 divided by 3 by 4 equal to 1 minus 0.05, which is nothing but 0.95, right? So what I can, okay, so basically we have to find out the value of c, right? Here. So here I can write down c minus 9.5 divided by 3 by 4 equal to fg inverse 0.95. Okay, so these value will be given to us. I think it's given here or not. Fg inverse 0.95. Okay, directly written, I think. Anyone tell me what is the value of Fg inverse 9.5? Okay, first of all, let me write down in equation.
1.64.
So it will be 3 by 4 Fg inverse 0.95. Okay, so basically C will be 9.5 plus 3 by 4 Fg inverse 0.95. Okay, so what is the value of Fg inverse 0.95?
1.64.
1.64. Okay, so let's write down C is equal to 9.5 plus 3 by 4 times 1.64. Okay, so let's calculate this. Okay, just calculate and let me know. So it will be, so it will be 9.5 plus 0.75 into 1.64. Let me calculate it. 9.5 plus it will be something 1.23. Okay, plus 9.5, so 10.73. Okay, so C is coming out to be 10.73. Basically, see, are you okay? So basically, this Fg inverse 0.95 1.64 is nothing but Fg of 1.64 will be 0.95, right? So 1.64 will be Fg inverse of 0.95. Is this clear? So basically, this abject value will be provided to you. Don't worry. Okay. So here we got the C value of C at 10.73. Okay. And what was our test? Our test was I will reject my H naught null hypothesis if X bar will be greater than C. Yes or no? And from the my sample, from the given information, what was my x bar?
9.5.
9.5. 9.5 or no? It's a 10, it's a at mu value. X bar was 10.2. Okay, be clear with the, no, don't take the mu value of mu with the x bar. Okay, mu was
Yes,
the
sir. It was
9.5, so
10.2.
10.2. Now tell me whether it is satisfying with the test. Just compare this thing with the value of C. Here 10.2 is less than 10.73, right?
Yes, sir.
That means what?
You accept the null hypothesis.
We can't reject the, yes, we'll accept the null hypothesis. We can't reject the null hypothesis. Is this clear? So that means, so here we cannot reject null hypothesis, okay, at alpha equal to 0.05. Till this point, it's clear?
Clear, sir.
Clear? Okay, so there was one something, if mu is 8.5 and alternative is mu greater than 8.5, let's do in this case, what is happening. Okay, so in the second scenario, if H0 is defined as mu is equal to 8.5, right? Alternative is mu is greater than 8.5, right? Then whether you will accept or reject. So I think if you will apply till this step, I will get the same thing, right? Only the difference is 8.5 and 9.5, right? So I'm doing directly. So C will be 8.5 plus it will be 1.23. Okay. So calculation will be 9.73, right? It will be 9.73. Now what was our test? X bar was 10.2. Now my test was I will reject my H0 if X bar is greater than C. Now if you see in this case 10.2 is greater than 9.73, this value of C. Yes or no? Right? Then what will be my conclusion?
We will reject the null hypothesis.
Correct. I will reject my null hypothesis if, I mean, at 5% level of significance. Okay. So basically, if you see, it depends on how we are defining my hypothesis. In the first scenario, we accept our null hypothesis, but while in the second scenario, we rejected our null hypothesis. Okay. Is this clear?
Yes, sir. Sir, can you take the second example also? It is not clear how we arrived at the variance in that. Can you please take that also?
Which one?
The same video, sir. The second example.
Second question. Okay. Second example in the lectures which sir has taken. You're talking.
Yes, sir. Yes, sir.
Okay. Okay. So this first question is clear. How will you apply Z test? Is this clear to everyone?
Yes, sir.
Okay. Fine. Okay. So if you doubt at any step, okay, please do let me know. So you are talking about second question. This is the first question. This one, right?
Yes, sir.
Suppose an app is desired to make an accurate identification, okay,
Yes,
of
sir.
faces in photographs more than 90% of the time in the long run. Okay. So, fine. For a random sample of 500 such photos, okay, so here n is 500, right? The app makes the correct identification 462 times, a 92.4% success rate. Okay, now, so let's write the things. What are the given the things? So here, if you see, what is my n? How many samples they are taking? 500, right? Basically,
500.
see,
Yeah.
this, if you see, this is something kind of Bernoulli, right?
Yeah. Yeah. Yeah.
I mean, whether the app is correctly identify or not, right? If app is able to correctly identify, it will take value 1 or else 0, right? So okay, we know the one information. If we will having some large samples, then I can convert into standard normal variate, right?
Yes.
Okay, so if you see now we will move to Bernoulli to then what else you can say normal, right?
Yes.
Okay. So n is 500. Why we are moving? Because we have large samples. Now, what is the samples? So basically, I can simply say x1, x2 up to x500. These all samples will be IID Bernoulli
Yes.
with some probability P, right?
Mm.
Now, what else information? It says, okay, for a random sample of the app makes the correct identification 462 times. Okay, so that means what? Okay, I will say simply xi will take value 1 when
Yeah,
is
identify
app
correctly. Yeah.
identified correctly, right?
Yes. Yes.
And it will take value 0 otherwise, right?
Mm. Yes. Yes.
Now, one thing is there, you can simply do what is okay, what will the distribution of x bar here?
X bar binomial.
Binomial, are you sure? Not binomial. Okay, before going to that, okay, okay, it's simply asking what does a G test tell about a null hypothesis that app is only 90% accurate compared to alternative hypothesis that app is more than 95% accurate. Okay, now that means, okay, what is the hypothesis? Is saying P is equal to 0.990%, right? And alternative is more than 95%. That means this is something
Right.
we have to test, right?
Yeah. Yeah.
Now, based on this sample, can you tell me, okay, before going to that, can you tell me if what will be the distribution of x1, x2 plus so on plus x500? It will be binomial. Sum of NIID Bernoulli random is what? Binomial
Yes, sir.
with 500 comma p.
Yes.
Yes or no?
Yes, sir. Yes, sir.
Now, tell me, what about expected value of this,
500 into P.
right? And what about variance?
500 into P. Sorry. P into 1 minus P divided by 500.
No, I just asked. See, this is the binomial random variable, right? Okay.
Yes.
Then
Yes.
let's say this is y. Expected value of y will be n into p,
Yes.
and variance of y will be n into p into 1 minus p.
Yes. Yes.
The thing you are telling, it's about x bar. Okay, let me tell you. So x bar will be what? X bar is nothing but it's x1 plus x2 plus x500 divided by 500, right?
Yeah. Yeah. Yeah.
Yes or no? Then this will be now this will follow the, can I convert into normal, approximately normal?
Yes.
Why I am converting into normal? Okay, first of all, let me go there. Okay, first of all, if this is the case, what will be the expected value of x bar?
So X mu only.
That is p,
Yeah.
right? Because if you apply expected value of x1 plus x2 plus x500, it will be 500 times p, 500 times p, and then 500 will get cancelled out, right? Basically, we will get p, right?
Yes.
And variance of x bar, it will be
Yeah. This will be P into
into
1
1
minus
minus
P
p
by
divided by,
500.
right? So far
Yes.
so good. Now, since we have large sample, then I can simply say x bar is basically I can say approximately normal distribution p comma p into 1 minus p divided by 500, right?
Yes. Yes.
So far so good. Now,
Yes.
one information in the question is given to us. For a random sample of 500 such photo, the app makes the correct identification 462 times. That means for this 500 samples, I can simply say x bar is what? 462 divided by 500. Yes or no?
Yes. Yes. Yes.
So this will be, can you calculate 462 divided by 500?
It's given 92 point. It's given in the question.
Yeah, correct. So 92.4%, that means 0.924, right? So
Yeah.
this is something okay. Did you get from where I got this 462 divided by 500? Because if you apply here, that means what? If you apply here, so 462 times they are getting 1 and remaining they are getting 0, right? I mean, it will be
Yes.
something 1 plus 1, 0 plus, I don't know, whatever, but 462 times will be 1 and rest of the time it will be 0, right? That is the meaning something, okay? So far, so good?
Yes, sir.
Now, So now tell me what will be your test now.
Sir, first the p value, like what will be the p? Like it will be 0.5 or it will be 0.9?
Which p value? This?
When you come down and calculate the variance, when
No,
you say that,
this p we have to estimate, right? We don't know this p. For this we are doing our test, right? Whether, see, in the question it says p is 90% and alternative is p is more than 90%. We have to test whether this claim is correct or not. Are you getting?
yes, yes.
Okay. So my hypothesis is this p is 0.9 and alternative is p is greater than 0.9. Now tell me what will be your test now? What will be your test?
Right tail test.
Right tail test, that's okay. How will you decide your test? I mean, what will be the statement?
Uh,
When you will
the
reject your H naught,
when it is greater than the critical value.
right? So test will be, I have to test, I will reject my H naught if X bar is greater than some critical value. Yes or no?
Yes,
If
yes,
it's less, suppose if something question says P is less than 0.9, right? Then your test will be, you will reject your H naught if X bar is less than C, right?
yes, yes,
Okay.
yes.
Why we are, okay, so you can simply visualize from here. In the right tail test, you will reject if X bar is greater than some critical value, right? In the left tail test, if it's less than some critical value, right? Yes or no?
Yes, yes, sir.
And for two tail test,
Sir,
what
but
it will be? It will be greater than something.
and less than.
And I mean, basically, I mean, simply you can say, I mean, modulus of X bar minus mu is greater than C.
Sir, but in question,
Hmm.
professor has directly inputted to arrive at the critical value.
Hmm.
Professor has directly inputted the value of the 0.9
Hmm.
to arrive at the critical value, sir.
Yeah, we have
Like,
used, okay, okay, the same thing we have done, right? We have to use that value.
no, no. Right now you
Hmm.
are telling. I asked you right now. You said that we have to calculate it.
No, no, no. See. Okay, you are, see, this information is given to us, and see, I'm simply saying that P is zero point 0.9. Okay, and
I am ask,
alternative is
I am
alternative.
I am
Yeah.
asking for
Hmm.
the X bar. You
Hmm.
decided that it is normal P and the variance is P 1 minus P by 500, right? Now here,
Okay,
what
you are
P
asking
value?
about this one.
Yeah, which P
Ah,
value
okay,
you
okay,
will
okay,
use?
okay. Basically, this is we have to take from the hypothesis one. This
No,
value
sir.
0.9. Yeah.
But sir, my question, that is my confusion actually.
Hmm?
Why we are using this value? Shouldn't, if you, whether the probability, if you look at, if the probability that the app identifies somebody or does not identify somebody should be
Hmm?
0.5, right?
No, no,
Why
no,
are
no,
we using 0.9?
no. Okay, just read the question carefully. What question says?
I read the question, sir.
Okay, see, please, try to understand. See, question, what is question saying? Identification of faces in photographs more than 90% of the time in the long run. Okay, for a random sample of 500 such photos, first of all, it's we are going to consider distribution of X bar. Okay, first thing. Second thing, see, it's Bernoulli P. Okay, it's not like half and half only. See, the claim is, if you read the question carefully, what is the claim?
It's
Claim is
90%.
more than 90%. Okay. So
Yes, yes.
by this claim, can you say it's a 0.5? Is it something correct? If you are saying, suppose I'm saying I'm making a claim that identification is more than 90%. As per your information, if you are saying, let's say X1, you are saying 0.5. Is this correct without testing?
No. Okay.
Not at all, right?
Yeah, yeah. So,
Correct?
basically, if the claim would be that it's 95, then for variance
See,
calculation, we will
yes.
have to use 95.
Basically, see, we are, if you see, if I will apply the alpha, okay, if I will apply the alpha, what is the alpha? Probability of rejecting H naught given the H naught. So what I will do, I will perform my test, I will proceed my test for this given value of for the given value of parameter. Whether, see, by using that value of the parameter, I will test whether I'm going to accept the claim or reject the claim. That is the procedure.
So basically,
Okay?
what you are trying to prove will impact not only your mean, but also it will impact the variance of what you are trying to.
See. That variance is the second thing. Okay. Key thing is we have to use that value, but see, by using that value, see, we have to, first of all, we have to find out the distribution of x bar. Okay. Since, okay, what is my test? X bar is greater than some critical value, right?
Yes, sir. Yes,
To
sir.
to proceed to perform our test, I have to convert in standard normal variable. To convert in standard normal variable, I need the variance and
Yes, sir.
expected value, right?
Yes, sir.
Now, to so how will you, okay, in that variance, if constant, I mean that like parameter is not there, you can simply use or else not. Okay, in the previous question, let's see, in the previous very first question, if you see, in the variance part, variance was given to us, right? We
Yes.
use the value of mu directly, right?
Yes.
Right. If suppose variance is unknown, I will use some value if there is some information is given to us or not, something like that. Okay, we'll see the same for t test or f test in further content. Okay. Now is it this idea is okay? Clear?
Yes, somewhat. Yeah.
Okay.
Yes.
Okay. Fine. So here x bar we got the it's normally distributed p comma p into 1 minus p divided by 500. Basically, see, this p can be anything. Suppose your claim is 0.8%, more than 0.8, then you will be using p is equal to 0.8 something. Okay. So here alpha is 0.05, right? And what is the rejecting h naught? It's a x bar is greater than some critical value, right? And h naught is what? P is taking 0.9. Yes or no?
Yes, sir.
Okay. Now, if you see, so this is 0.05. What is the next criteria? I have to convert in standard normal variable. So x bar minus what is the expected value? P divided by square root of variance. I mean standard deviation. I mean we have to divide by standard deviation. It will be P into 1 minus P divided by 500. Yes or no? Greater than C minus P divided by square root of P into 1 minus P divided by 500, given that P is 0.9. So far it is clear. It will be 0.05 probability that, what about this quantity? It will be G, right? Greater than C minus, what is the value, which value we have to use of P? 0.9, right? It will be 0.9 divided by square root of 0.9 into 1 minus 0.9 divided by 500. Okay. So what is the value for this thing? Okay, first of all, before that, we have to convert in CDF format. I mean capital F, I mean CDF. So it will be 1 minus probability Z less or equal to C minus 0.9 divided by square root of 0.9, 1 minus 0.9 divided by 500. Okay. What is the okay, okay, before, so that means from here I can simply write uh probability G less or equal to, okay, so it will be 0.05 equal to 1 minus fg of these things, right? C minus 0.9 divided by square root of 0.9, 1 minus 0.9 divided by 500, right? Then next step will be fg of this thing, C minus 0.9 divided by square root of 0.9, 1 minus 0.9 divided by 500 equal to 1 minus 0.05, which is nothing but 0.95. Okay. So basically, what is the, can you tell me what is the final value in calculation of this part? So it will be 1 minus this is 500 equal to fg inverse of 0.95. And we know this is the I mean, this will be 0.9 plus square root of 0.9, 1 minus 0.9 divided by 500 fg inverse of 0.95. Okay, what is the final value in calculating the lecture video? Can you tell me? 0.922. Okay. Now, if you see what was the value of x bar? X bar was 0.924, right? And we got C as 0.922. Okay. So, will you reject or accept? Here,
Reject.
x bar is greater than C. That means I will reject my H naught. Okay. Is this clear? Okay. So should we do one question related to two-tail test? I think next one is
Sir, the PDF of lectures are not uploaded.
which PDF?
Sir, the lectures sir had taken.
This PDF.
Yes, sir.
Will you-
Lecture 1, 2, and 3, 4, 5, 6. Of lectures sir taken one.
No.
PDF of these lectures are not uploaded.
Okay. So please check the. Had you checked in supplementary content,
Yes, sir. I checked.
lecture PPTs and slides?
Yes, sir. Yes, sir. I checked.
Okay, we'll check. We'll check. Okay, we'll cross check whether it's had been there. It's there or not. Okay. Okay. So let me do this. Thing. Just a minute. Okay, this is the question, right? For two-tail test. Okay. Okay. So single. Okay. One-tail test is clear to everyone. The first right tail test and left tail test. It's okay.
Yes, sir.
Fine. So let's do this problem number 3. Okay. Okay. So if you see what we had done in two tail test, how will you decide the rejection region and all? So at the beginning of the session, we told, right? So this will be, suppose this is your Z alpha and this is your minus Z alpha, and this suppose P peak as Z equal to 0. Okay. So you will reject your test if null hypothesis less than, your Z value is less than minus Z alpha and this value is greater than this Z alpha. Basically, this is the alpha by 2 and this is the alpha by 2 because we are taking about two-tail test, right? Now, so let's come to the problem statement. So if you see x follows normal mu comma 36, yes or no? This is normal mu comma 36, and it says n is equal to 25 IID samples of x. So there are n equal to 25 IID samples of x, right? Now the observed sample mean is 6.2. That means x bar is 6.2 given to us. Yes or no? Now what will be the distribution of x bar? From if you have x1, x2 up to x25, these all are IID mu comma 36. What will be the distribution of x bar? Tell me. What will be the distribution of x bar?
Normal mu comma 36 by 6.2.
Normal mu comma
36 by 25.
right? Okay, this is clear to everyone. Yes or no?
Yes, sir.
Okay, fine. Okay, so what's the information? So hypothesis is given to us mu is equal to 4 and alternative is mu is not equal to 4. Okay, so hypothesis is mu equal to 4 and alternative is mu is not equal to 4. Okay, so in right tail test and in one tail test, how we decided our test? Okay, so for right tail test, we will reject our h naught if x bar was greater than some critical value. Now, what about this case? Mu is not equal to 4. That means what? Okay, so okay, let me tell you. I will reject my h naught if modulus value of x bar minus mu will be greater than some critical value. What do you mean by this one? So simply I can say x bar is greater than x bar is greater than some mu plus c, or x bar is less than mu minus c. Okay, these two both sided we have to check. Yes or no? If you see, this is something ball. We have to check this left side, and we have to check the x bar is greater than some mu plus c and x bar is less than some mu minus c. We have to check. Is this clear?
Clear, sir.
Clear for everyone? Okay. So what should be the first next step? Now you will tell me. I will only then I will write. What should be the next step? In the previous question, how did we proceed? After this, we proceed with the alpha, right? Yes or no?
Yes.
See, let me clarify one thing. If you are not speak, whether you are getting or not, I will assume you are getting. I will simply solve the question. I will close the session. Okay. Okay. So after this, basically we have to proceed with the probability of type 1 error. Okay. So what is the alpha? Alpha is nothing but probability of rejecting H naught when H naught is given to us, right? And what is the alpha? Alpha is in the question it says we have to take the 0.05. Okay. So we'll take this value at the end. So okay, if you see what is the when you will reject H naught, when my x modulus of x bar minus mu is greater than some critical value, and given that mu equal to 4. Yes or no?
Yes.
Right.
Yes, sir.
So if you see, okay, what is the next step? X bar is see we have information x bar following normal what is that mu comma 36/25. What is the next step after this? We have to convert into standard normal variable, right?
Standardized. Yes, sir.
Yeah, we have to standardize. To standardize this, what we have to do? We have to okay. It's already subtracted by its mean. That means we have to divide by only by the variance. I mean standard
Standard
deviation,
deviation.
right? So I can simply say modulus of x bar minus mu divide by 6 by
6
5,
by 5.
6/5.
and this will be, and here if you see we have to do the same thing on both sides. It will be c divided by 6 by 5, right? Make sure don't subtract here mu, mu for the c. Why? Because it's already subtracted, right? Are you getting?
Yes.
Okay, so it will be modulus of g greater than 5c divided by 6, given that mu is equal to 4. I mean this is something we can see here, mu is equal to 4. We can use already here. I mean now there is no mu, it will be something like that. Okay. Okay, what is this? Modulus of g greater than 5c divided by 6. What I can write? I can simply say z is greater than 5c by 6, or z is less than minus 5c divided by 6. Yes or no?
Yes, sir.
Okay, now if you see, due to see this z is standard normal variable, right? So this will be z equal to 0, and I'm saying this is suppose 5c divided by 6, this is minus 5c divided by 6. Okay, so what I'm saying, this area and this area, yes or no?
Yes, sir.
Since okay, since due to symmetricity, can I say probability of z greater than 5c divided by 6? This will be same as probability z less than minus 5c divided by 6. Yes or no?
Yes, sir.
I can simply say, right? So if you see now, if you it will be alpha equal to probability that probability z greater than 5c divided by 6 plus probability z is less than minus 5c divided by 6. And we know due to symmetricity these two will be same. So I can simply say probability that, so let's use less than sign because we have to convert at the end in the fz terms, right? So plus probability z less than minus 5c divided by 6. This is the 0.05. Now we can use. So 0.05, it will be 2 times probability z less than minus 5c divided by 6. Yes or no? Now it will be probability. No, yeah, probability z less than minus 5c divided by 6. It will be 0.05 divided by 2, right? And it will be fg minus 5c divided by 6. It will be, let's make it 0.05 divided by 2 for now. Okay, what will be the next step? I can write minus 5c divided by 6 equal to fg inverse of 0.05 divided by 2. Okay, so what's the final value? Okay, so we will provide the final value in the during the examination. So fg of 0.05 divided by 2. Okay, so okay, c is okay. Okay, let's say from here c will be minus 6 by 5 fg inverse of 0.05 divided by 2. So the value in the lecture we got 2.352. I'm using directly. Okay, so this value will be provided to you, don't worry. Okay, I mean it will be provided like this. Let's say fz 1.64 is 0.95. Okay, so that means 1.64 will be fg inverse of 0.95. Are you getting? Okay, this is something
Yes,
will
sir.
be provided. Okay, now when you will reject your h naught, we decided I will reject my h naught if modulus of x bar minus mu will be greater than c. Now, okay, what is the mod x bar? X bar was how much? 6.2, right? And what is the mu? Mu we have to use the 4, right? What is this value? This is 2.2, right? And what is the value of c here? 2.352. So this is the less than this value. Okay. Now that means what? What will be my conclusion? I will accept my null hypothesis. Is this clear?
Yes, sir.
Sir, can you up the slide?
Okay. Where?
Li- a little bit up.
Okay.
Yes, sir, sir. If we solve without putting 4 on the place of mu, what will
It's fine.
happen?
It's fine. It's fine.
It,
It's fine. It's fine.
it is same as probability of z mod z is greater than 5 6 5
Yes.
6
Yes. Yes. No problem.
5c by 6.
Yeah. Yeah. Yeah.
Okay,
Basically,
sir.
what we are doing, we are just putting the mu. Okay. We are putting the value of mu. It can be 4. It can be 8. It can be 6. I think next statement is mu is equal to 8. Okay. But key thing is it will be z. Okay.
Sir, the
Hmm.
after the slash mu is equals to 4, it will not affect the answer.
Yeah. 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 Okay, for example, suppose there is something c minus mu, then you have to put the 4 here itself. Okay, but it's not there. Okay,
Okay, sir.
okay. I mean you can see in the very first question we had done here it one. Yeah, you can see we had to subtract mu and we put it the, okay, so this is you have to put the 9.5 here, and then we have here it was c minus mu, then we have put the value of mu here itself. Okay, but in that this
Okay,
question there was not in mu. Okay,
okay, sir.
is this clear to everyone till this point?
Yes, sir.
Okay.
Yes, sir.
Okay, let's verify this one. Okay, null hypothesis mu is equal to 8 and alternative mu is less than 8. Okay, so second scenario is h naught is mu is equal to 8 and alternative is mu is less than 8. Now what will be your test? So this is, okay, this is not if you see this is only left tail test, right? Okay, in left tail test my what will be my test? When you will basically when you will reject your null hypothesis, tell me. If this is,
Not less than 8.
sorry,
If mu is less than 8,
that is the alternative hypothesis. I'm asking what will be your test when you will reject your H naught?
X bar less than 8.
X bar is less than not 8. X bar is less than some critical value.
Some critical value. Yes, yes.
Yeah, that is something you have to take care of it. Okay. Okay. See, in right tail test, you will be deciding you will reject your H naught if X bar is greater than some critical value. Okay. Now, what will your alpha? Alpha is nothing but probability of reject H naught if H naught is true, right? This is something alpha. Alpha is 0.05. What is the reject? Now, if you see, this is change, right? X bar is less than some critical value, and H naught is mu equal to 8, right? Now 0.05, and now we have to convert in standard normal variate. Okay, what is the distribution of X bar? It was normal mu comma 36 divided by 25, right? So it will be X bar minus mu divided by 6 by 5 less than C minus mu divided by 6 by 5, given that mu is equal to 8, right? So we have to use the value of, okay, so basically it will be X bar minus 8 divided by 6 by 5 less than, now here you will see, if you observe, we have to subtract the mu, right? In the previous it was not there, right? Because mu was already there, subtracted, right, in the modulus case. Yes or no? Right?
Yes, sir.
Now here we have to, it will be C minus 8 divided by 6 by 5. So this will be G less than 5 C minus 8 divided by 6, and it will be 0.05. Now it will be 0.05. It will be Fz of 5 C minus 8 divided by 6. Okay. Now it will be 5 C minus 8 divided by 6 equal to Fz inverse of 0.05, right? Okay. So next step will be, basically it will be C minus 8 equal to 6 by 5 times Fg inverse 0.05. Okay, it will be C equal to 8 plus 6 by 5 Fg inverse of 0.05. So I will use the direct. What is the value? So this is 6.02. Okay. So this is 6.02. So now we got C as the 6.02, and X bar for my sample, it was, I think, 6.2, right? Yes or no?
Yes,
Now, now our test was, I will reject my H naught if X bar is less than C. But if you see, this X bar 6.2 is greater than 6.02. That means what? You will accept your null hypothesis.
This is.
Okay, is this clear till this point?
Yes, sir.
Yes, sir.
Okay. So basically, you have to see the case, you have to observe the case, how, I mean, how your null hypothesis and alternative hypothesis has been defined. So, for example, your null hypothesis defined, let's say mu is equal to taking some value mu naught, and alternative is defined as mu is greater than mu naught. That means this is the right tail test. Okay. So this is right tail test. So my test will be, I will reject my H naught if X bar is greater than some critical value. Okay. Then what will the next step? You have to compute the alpha, which is probability of reject H naught given that H naught. So alpha will be probability of X bar greater than C, that mu, there is some particular value mu equal to mu naught, right? That is something you have to proceed, and then convert in standard normal variable, and basically from the given sample identify the distribution of X bar, which is normal something, let's say mu comma sigma square by n. Okay. Now if my hypothesis is defined as mu is equal to mu naught, and alternative is defined as mu is less than mu naught, that means this is left tail test, right? And this is, if this is left tail test, then what will be my test? You will reject your null hypothesis if, tell me,
X bar.
is less than some critical value. Okay. And alpha, then the same thing, probability of rejecting H naught when H naught is true. And what is the case here? X bar is less than C, and H naught is mu equal to some given value of mu, right? And this will be, alpha will be given to you whether 0.05 and not. Okay. Suppose there is another scenario, H naught is defined as mu equal to mu naught, and alternative is something mu is not equal to mu naught. That means this is the two-tail test. Okay. So this, if this is two-tail test, so then I will, how will I define my test? My test will be, I will reject my null hypothesis if modulus of x bar minus mu will be greater than c. That means x bar is greater than some mu plus c, or x bar is less than some mu minus c. That is meaning. So that means alpha, next step will be alpha probability of, rejecting h naught. When h naught is true, that means it will be, let's say alpha, it will be modulus of x bar minus mu greater than c, given that mu is equal to mu naught.
May not.
Okay, so this is all about different kind of test which we have to use for the, like, what you can say,
Z test.
yeah, jet test in different kind of scenario to use. Okay, okay, is this clear to everyone?
Clear, sir.
Yes, sir.
Clear for, okay, now,
Right.
okay, so problems related to jet test. Okay,
Yeah.
Yes, sir.
so do we move to the next kind of, okay, how many of you watched the lectures video of any lecture video of week 12?
Not
Not
fully
yet.
covered.
Sorry,
Uh, I didn't. I haven't finished the whole lecture. I mean, some of it is left.
some pending is there, right?
Yes, sir.
Okay, no problem. Okay, what about others?
Partially, yes, sir.
Not even started.
Partially. Okay, okay, no problem. Then accordingly, we'll see what we can do. Okay, so there is one lecture, right? Lecture 11.8, right? More problems on G test. Okay, so prefer this more problems on G test also. That will be very helpful, because in 11.8, if you go through more problems here, right? So there will be some questions where there is no need of fz value. I mean, for some binomial kind of uh, problems. When? Because suppose there is some small samples, okay? Then if binomial distribution is there and you will have some small samples less than, I mean, in statistics, basically we are considering the last sample if n is greater than 30. Some books taking greater or equal to 30, greater to 50, but we are taking greater than 30. Okay, so if you have, suppose, okay, for example, suppose I'm saying I have small samples n equal to 10, and samples are of x1 x2 something. These all are Bernoulli, or let's say binomial, something like that. Okay, then if I want to apply this hypothesis testing, so can I convert into FJ test? Can I convert into FJ form? Can I convert?
So using central limits theorem.
I'm asking, can I convert for this and
Yes.
how? Then I can convert in normal distribution, any other distribution?
Sir, by
If we
subtracting expectation and dividing by standard.
That's okay, but there is one scenario I can convert into only one case. If you are applying the central limit theorem, n should be large, right?
Yes, sir. Yes, sir.
Okay.
Okay.
So n, if n is 10, you can't convert in standard normal variable. If it's any other distribution, Bernoulli, binomial, and all. If x is already normal distribution, I can simply convert into standard normal, whether n is small or large, doesn't matter, right?
Yes, sir.
Oh, yes, sir.
Are you getting what I'm trying to say? Okay. Okay.
yes, sir.
Only
Yes, sir.
there is one problem in this is very first question. Okay. So why I'm trying to say, because in some questions, sometimes you will not get fz value. That means you have to use something. Okay. Let me do this question. After that, I will move to the concept of Week-12. Okay. So question number one is saying vaccine hesitancy. I mean, that is the something percentage of people who are unwilling to vaccinate in a town has been reported to be 20%. What is this 20%? This is something P, right? P is 20%, 0.2, right? To test whether the fraction is 20%, you call randomly a selected group of 10 people, right? So now if you see what is N, let me start from the very here. So what is the N? N is something 10 people we have selected, right?
Yes, sir.
Find out that three of them are vaccine, and hesitance, right? Vaccine hesitance. Now, what is this? I mean, this 3. What do you mean by this 3?
H naught.
Success is not.
I mean, yeah, basically, I mean, let's say, okay, I will come to that one. Okay, I will. Basically, this out of 10, we found out sorry, not T, 3 of them are vaccine hesitant. What is the null hypothesis? Will you accept or reject the null hypothesis at a level significance 0.05 against the alternative that fraction is above 20%? Okay, alternative is saying fraction is more than 20%. That means, okay, what will be my null hypothesis? P equal to 0.2, right?
Yes, sir.
Now, so far it is okay.
Yes, sir.
So as per the given information, I will say x1, x2 till x10. These all are IID Bernoulli P, right?
Right, sir.
Right. Now, when you will reject your H naught, okay. So basically, if you see, we are here interested in count, right? Basically, count of the people, how many of them are reported for vaccine hesitancy, or whether they are unwilling to do or not, right? So we are basically, I'm interested in count. Okay, if these are Bernoulli, then suppose I'm defining a random variable t x1 plus x2 plus till x10. That will be what? Bernoulli, sorry, binomial with
Yes, sir.
parameter 10 comma p.
P.
Sum of NIID Bernoulli random variable is nothing but the binomial, right? Okay. So when you will reject, okay, what will be your test? Test will be you will reject your H naught when, if, tell me.
If
T
T
is greater than C.
T is greater than C. Actually, this you can take, this T is nothing but represent the number of people, right? Who, I mean, who are unwilling, basically unwilling for the vaccine, right? Number of total people in the selected random sample, right? Yes or no? Or you can simply go with the X bar is greater than C. I mean, you can, okay. Here, if you see, distribution of T is nothing but binomial 10 comma P. If you convert in X bar, it will be binomial. Then expected value will be P and variance will be P divided by, sorry, P into 1 minus P divided by 10, right? So you can go with, I mean, with any one of the approach. Okay. So what will be alpha? It will be probability of rejecting H naught. Yeah.
Sir, how did you decide this test that T will be greater than C? Can you please explain?
Okay. What is your null alternative hypothesis? This is right tail test,
P should be greater than 0.2.
right? So
Yes.
we just few minutes before we had discussed. If you have right tail test, let's say about mean, I will say I will reject my H naught if X bar is greater than C. Okay. Why we have seen by visualization also. This will be your Z alpha. This is your Z equal to 0. Okay. I will
Yes,
reject
sir.
it right tilted that if my critical value is more than this one. Okay. I mean sample value, let's say X bar will be more than this. Okay. So this is
Okay, sir.
something, yeah, I would say, okay, this is something you can go with X bar is greater than C also, no problem. The only difference, distribution will change. Okay, here T is binomial 10 comma P means expected value of T is 10 into P, variance of T will be 10 into P into 1 minus P, right? If
Yes,
you will
sir.
take X bar is greater than C, the only difference expected value of X bar will be P, variance of X bar will be P into 1 minus P divided by 10. Okay, you will get the same result. I am going with the simpler approach. Okay, I will do both, no problem. So alpha is 0.05 and rejecting H naught is T is greater than C and H naught is P is equal to 0.2, right? Yes or no?
Yes, sir.
Now tell me, I will do 1 minus probability T is less or equal to C given that P is equal to 0.2. Now, can you tell me, can I convert T into standard normal variate? Yes or no?
No, sir.
We can't because and we have small samples, right?
Sir, N is small.
So we have to do basically, we can do 1 minus it. So that means, this means what? We have to add all the things, let's say K is equal to 0 to C, right? And what is this? How will you find this? I mean, suppose I'm saying x is following binomial, let's say 5 comma half, then tell me probability x less or equal to 1. That means what? You have to add the probability x equal to 0 plus probability x equal to 1.
Yes, sir.
Right? I mean, here x will take value 0, 1 to 5, right? So that means
Yes.
here my t will take value 0 to c.
To
I mean, we have
see.
to add all the probability till k equal to 0 to c. Are you getting?
Yes, sir.
And what is the PMF of binomial? N choose x, right? So to be 10 choose k, and p raised power k, 1 minus p raised power 10
And
minus k. Okay. So these all things you have to add up basically. Okay. Is this clear? What I'm trying to say here? Okay. So here p, you can simply substitute the value of p as 0.2 and it will be 1 minus 0.2. Okay. You will get the answer.
sir, this 0.05, this is given in the question, sir.
Yeah, this is alpha. Alpha will be given to you. Whether
Okay,
you
sir.
to whether your level of significance is 0.05 or 10% or any other anything else. Okay.
Okay, sir.
Yeah. Okay. Okay. So till this point, it's clear to everyone. When you can use your FZ and all single test, right tail test, left tail test, two tail test.
Sir, one thing.
Yes.
This the number of samples, if less than 30, then we will, in that case, we will be using such things. You said 10, 30 is large. After 30 is
Yeah,
large.
see, basically in statistics, if n is greater than or equal to 30, we are considering as a large sample. Okay.
Right, right.
So if
So
suppose,
here,
okay, suppose here it was n equal to 10. Suppose n
right,
is
right,
50 is there, 100 is there, then I can simply convert in standard normal
right, right,
variate
right,
as
right,
by using the central limit theorem.
right, right, sir.
Got it?
Right,
Okay.
sir.
So just
So any n which is less than 30, I have to use this way.
no, it's not about only this way. This was the case of Bernoulli. Suppose there is case of poison.
Right, 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 right,
Okay.
right,
So
right,
the key thing I was trying to say, if n is large, okay, and
right,
irrespective of the previous distribution, I can convert into the normal distribution by
right,
using the central limit theorem. Okay.
right, sir, right, sir.
Suppose n is already 10 and my distribution is already normal distribution.
Right,
I can simply convert in standard normal value because I'm my big initial distribution is already in normal distribution, right?
right, sir. Got it, sir. Got it. Thank you.
Okay, so just give me 1 minute. I will be back. Okay, then we'll start the week 12 content. Hello, am I audible?
Yes, sir.
Okay,
Yes, sir.
okay, so just is my screen visible?
Yes, sir.
Okay, so so far we have seen for one sample Z test. I mean in Z test, variance is known to us, right? And to test for the sample mean, we are using the Z test. Okay. Now we'll move to some different kind of some another type of test. Okay. So that is called something T test. Okay. And chi-square test. Okay. And two sample. See, so far we have seen some for one sample and all, right? Then we'll see for the two sample Z test, F test, T test. Okay. Now, okay, tell me what was the scenario? Suppose I'm saying I have x1, x2 up to xn. These all are IID normally distributed with mean mu comma sigma square. For example, okay. Then what is your? How will you define your x bar? I mean summation of xi divided by n, right? Yes or no? Then
Yes,
what was
sir.
the distribution of x bar? It was normal mu comma sigma square by n, right? So this is the distribution of x bar. If so, there is something called chi-square distribution. How many of you heard about chi-square distribution? Okay. Okay. Fine. Okay. Okay. If this is x bar is normal distribution mu comma sigma square by n, then what about distribution of x bar minus mu divided by sigma by root n? Tell me. What will be the distribution of this?
So it will the
0,
standard.
1.
Correct.
0,
It's a simply standard, right? Okay. So and okay, so be clear with this. I mean, you will. This is something important. I mean, you may get some questions related to these kind of questions. I mean, in the end term. I mean, if distribution is this, what kind of distribution will be for that? Okay. Now, so there is something called chi-square distribution. Okay, this is before going to chi-square distribution, I will tell you if this is normal standard normal distribution, right? So there is one called t-test. So t-test is nothing but it's defined as x bar minus mu divided by s by root n, and this is called distributed with t distribution with n minus 1. So basically, this is called t distribution with this n minus 1 is called n minus 1 degree of freedom. Okay, this is just a terminology. Degree of freedom. I mean, degree of freedom will yesterday further. Okay, I mean in depth. So basically, we can use the teach. If you see this form is the same as this one, right? What is the difference? Difference of sigma. In case of normal distribution, the population variance is known to us. Okay. In case of t distribution, the population variance is unknown to us. I mean, we don't know the population variance. So that is the difference between t-test and normal distribution. I mean, see, if you see the form is same, right? This is something I can use to test the mean. I can use this is for the mean, right? Z-test for mean, t-test for mean. What is the main difference? When variance is unknown to us, I will prefer t-test, and when variance is known to us, I will prefer the Z-test. Okay, basically this is called the Z and this is called the T. Are you getting some rough idea? So this,
So would you please repeat?
yeah, I will repeat. So this S is nothing but the sample variance. Okay. Okay. So far what we have done, we had discussed Z test, right? How would you define your Z test for mean? So Z test for mean is nothing but suppose you have some x1, x2, let's say some xn IID samples from X. Your X is defined as normally distributed with mean, comma sigma square. This sigma square is known to us. Okay, it will be given to you. Okay, then if you want to apply your Z test, then it will be simply x bar minus, you have to convert x bar minus mu divided by sigma by root n. I mean, you have to convert in standard normal variate, right? That is something we had done.
Yes, sir.
Now, if you see the now, so there is something called another test called t-test for mean. Okay, how we are using this t-test when variance is unknown to us. Okay, we don't know the population variance. Okay, so then main formula is nothing but for this t-test. So it's nothing but T is equal to x bar minus mu divided by S by root n. This is follows T and minus 1 degree of freedom. So this n is nothing but this is something sample variance. Okay. So whenever you have to test for mean, okay, so there is two tests, Z test and T test. You will be using Z test when variance is given to you, known to us. If variance is unknown to us, then you will be using the T test. Means you have to convert the X bar in the form of T test, not in the Z test. If you see the problems related to Z test which we have done, so in the information of the question, if you see variance is given to us, right? 36. Yes or no?
Yes, sir.
Right, variance is known to us. And if you see in the previous question also, variance was given to us, right? If variance is unknown to us, I will be using the, I will prefer the T test. Okay, criteria is same. I mean, to define the reject, I mean, like test and all. I mean, suppose I'm saying my null hypothesis is something mu is equal to mu naught, and alternative hypothesis is something, let's say mu is greater than mu naught. Okay, for example, then my T will be x bar. Let's say T is the x bar. So what will be my test will be, you will reject h naught when x bar is greater than some critical value, right? Or I will say T is greater than some critical value, because here T is nothing but I'm taking as a sample. You can say T or anything. Okay, now if you see here, since we don't know the population variance, right, that means sigma, that's why we are using the sample standard deviation in the denominator. Okay, are you getting? Are you getting this idea, some rough idea? In which scenario you can use your T test?
Yes, sir.
Okay, when you will you prefer to using your T test? When you don't know the population variance, right? Okay, let me take one example that will give you some, I think it should be some other lecture. I'm taking the examples from T test. Okay, let me take this very example. But I'm taking because to know the values, I mean, because otherwise we have to calculate the value. This value will be provided to you. Don't touch. Okay, suppose this question, if you see in this question, what is the information given? Suppose x is following normal mu comma sigma square, right, with unknown sigma. Okay, for if you see one more important thing, T test we are using for the small sample, not for large sample. If you see, if sigma square is given to us, then I can directly use the Z test. Yes or no? But in this question, it is clearly mentioned that x follows normal mu comma sigma square with unknown sigma. By seeing this information, if you want to test for mean and variance is unknown, that means I will prefer the T test. Okay, and T test is for a small sample. Okay, for n is equal to 16 IID samples of x, the observed sample mean is 10.2. Okay, let's write the what is the information given to us. So we have given x is following normal mu comma sigma square, and I'm saying this is unknown. By seeing this information, we have to come at the decision. I will prefer the T test. For n equal to 16 IID samples, so n is given to us 16 IID samples of x. Observed sample mean is 10.2. That means what? X bar is given to us. X bar is 10.2, right? And sample standard deviation is 3. That means S is given to me as 3. Yes or no? What conclusion would a T test reach if null hypothesis mu is equal to 9.5 and alternative mu is greater than 9.5? So null hypothesis mu is equal to 9.5 and alternative is nothing but mu is greater than 9.5. Okay. So now if you say variance is unknown to us, that means I have to use the T test, right? Okay. So if you see, now, so what, okay, what will be your test? First of all, I will reject my H naught when, if, yeah, tell me.
X bar is greater than C.
X bar is greater than C by right tail test. Now tell me, what will be the distribution of X bar first of all here? It will be normally distributed mu comma sigma square by n, right? Yes or no?
Yes, sir. Yes, sir.
Okay. Now tell me one more thing. So what is the first step after this? I have to proceed with alpha. So alpha is probability of reject H naught given that H naught is true, right? And what is the rejecting H naught? X bar is greater than C given that mu is equal to 9.5. Now, if you see variance is unknown to us, that means if X bar is here normally distributed mu comma sigma square by n, since variance is unknown to us, that means if you see, if I will write down X bar minus mu divide by, if variance is unknown to us, that means I have to use the sample variance, right? Okay. Okay. Why we are using sample variance? Anybody? There is was one concept in I think in
Yes,
week 7.
because of the expectation of sample price is same.
Correct. Basically, this is, you can simply say sigma square hat is S square. Hat means this is one of the estimate. Okay. So if this is unknown to us, I can use the sample variance. So it will be S by root n. Yes or no? Greater or equal to C minus mu divided by S by root n. Given that mu is equal to 9.5. So far so good. The same procedure which we are doing in Z test. Now, since this is the sample variance, it will be T, right? Okay. And what is the N? Before going to that, let me write down the things. X bar mu is 9.5. Sample variance is how much? 3, right? If I'm not wrong. And N is 15. 15 or 16? 16. Right? And greater than C minus 9.5 divided by 3 square root of 16, right? So far so good. Any doubt?
No, sir.
Okay. What you will write this one now? Tell me. What will you write? In the J test case, we were writing capital Z, right? But here, what we will write? We know X bar minus mu divided by S by root n. I will write as a T n minus 1 degree of freedom, right? Here n is 16, so I can simply write T 15, 16 minus 1. Yes or no?
Yes, sir.
Okay.
And this will be greater than C minus 9.5 divided by 3 by 4. Right? The steps are
Yes.
very similar. I mean, it's
So,
approximately
sir,
Hmm.
sir, will it to be T table or?
Yeah, it will be T table. We will, if there is T test, we will provide the values related to this. In the previous, we will take the FZ value. I mean, standard. I mean, we will prefer the Z standard normal table, right?
Yes, sir.
Now,
Yes, sir.
in this case, we will prefer the T table. I mean, there is one table for tabulated value of T test. Okay.
Then, sir, really sorry, sir. Then, sir, I solved the question by
Hmm.
just finding the T and just comparing with the alpha.
Right.
It
Fine.
it always uh, actually I solved the question by
Hmm.
using T value. T is equal to X bar minus mu naught divided by sigma divided by under root of n.
Hmm.
And find out the T value and comparing with alpha and I got if the T table means I need to be a DF in a
Yes.
that value.
Yeah.
So by the T table,
Hmm.
I finding the T table value and I already have T calculator value. I compare both. Cool.
No.
This is a good way.
Okay, you are talking about you are calculating and you are tabulated value, right? I mean,
Comparing with the
basically,
calculator.
okay. There, I think you are trying to do in different way. I mean, basically, you are calculating this value, right? This value, right? And then
Yeah.
you are computing the T value of tabulated. I mean, T distribution. Tabulated means the value from the table at 15 degree of freedom,
Yes.
right? Yeah, you can do this. That's not a problem.
Okay, because that give direct answer. No
Yeah,
need
yeah, no
to
problem.
like
This is
this
also
question.
a good one. I mean, basically, this is a why we are proceeding, because we are proceeding as per the like I mean, like we have defined our test, right? Accordingly, we are proceeding here itself. Okay. So if you see in the previous, we had converted in FZ value. Now I can write these things F. Now it's not Z, it's the FT15, right? So it will be C minus 9.5 divided by 3 by 4, right? So next it will be FT15. That is, this is CDF value. Okay. So this is something we will provide. Okay. Or you can check from the I mean tabulated value of T distribution. Okay. It will be 0.95. Okay. Now, if you see C minus 9.5 divided by 3 by 4, it will be FT15 inverse of 0.95, right? Steps are very similar. Okay. So it will be C equal to 9.5 plus 3 by 4. Okay. FT15 inverse of 0.95. Okay. So this value we will basically provide. So let me check the value direct. Um, let's see. Okay. So they got the value as 10.81. Okay. So final value of C is 10.81, right? We had decided our test, how we will reject H naught, right? If X bar is greater than some C, right? X bar was how much? It's 10.2, right? So now if you see 10.2 is less than 10.81, right? That means what? I will accept my H naught. Okay. Is this clear? Are you getting the idea? When you will use your T test, first of all, tell me.
Yes, sir.
When I don't know the population variance, right?
Yes, sir.
If I don't know the population variance, I will convert into the, I mean, I will proceed with the T test, not with the Z test. Is this okay?
Yes, sir.
Oh, fine.
Yes, sir. Yes,
So
sir. Okay.
there is one more test called chi-square test for variance. I mean, see, so far we have done test for the mean, right? What about test for variance? Okay. So we are using something called chi-square test. Okay, we will use chi-square test. What is that? Let me define. Suppose I have this is a notation for chi-square. If I'm writing chi-square and this means chi-square distribution with, I mean chi-square random variable with n degree of freedom. Okay, so basically suppose I have x1, x2 up to xn. Let's say these are IID normal. Okay, mu comma sigma square. Okay, now so far we have done test for me. Okay, now suppose what about I'm defining the hypothesis as per my variance. I mean, let's say I'm saying this sigma is some equal to some sigma naught. Okay, and alternative is this sigma is greater than some sigma naught. Okay, that might be a question, right? Then how will you proceed uh, for this kind of test? Okay, so we'll proceed with the sample variance. Okay, so okay, see, for the mean, to test the mean, hypothesis was about in terms of population parameter mu is equal to some mu naught, mu is greater than some mu naught, or mu is less than some mu naught. Yes or no? Okay, but here we will proceed with the sample variance. Okay, so what is the sample variance? How I will define? It's nothing but 1 upon n minus 1 summation I to n xi minus x bar square, right? This is something we are defining sample variance. Now tell me what will be your test by just relate with the sample mean. In case of mean, when you will reject your h naught? If you see in the case of sample mean, where it came, yeah, okay. In the case of sample mean, if my hypothesis is mu is equal to mu naught, mu is greater than mu naught, then I will reject my x naught if sample mean is greater than some critical value, right?
Yes, sir.
Then if h naught is sigma is equal to sigma naught, mu sigma is greater than some sigma naught, then when you will reject your h naught? Tell me, just think, just think. It was mu equal to mu naught, mu is greater than mu naught. We decided I will reject my
Then
h naught is f x bar is greater than some c, right?
So S square greater than
sample
some C.
variance when greater than
Yeah, here my
C.
hypothesis defined in terms of standard deviation. Then I will simply say s is greater than some critical value. Yes or no?
Yes, sir.
Yes,
I,
sir.
I can define, right? So what is the chi-square distribution first of all? Chi-square distribution is defined as nothing but n minus 1 times s square divided by sigma square. It follows chi-square n minus 1 degree of freedom. This is something chi-square is defined. Okay, I mean n minus 1 times of s square divided by sigma square. Okay, so let me proceed. Okay, if this is the test, what will be your alpha? See, key thing is you to observe, if we have to test for variance, sigma is equal to sigma naught or sigma is greater than sigma naught, I will go with the chi-square. But to convert in chi-square, we must know we must be aware about the form of the chi-square, right? Initially, we converted to test for the mean, we converted into the Z test form, right? If variance is known, if variance is unknown, we converted into T test form, right? But if for sigma, then I have to convert in in the form of chi-square. So how will you proceed? So alpha is what? Probability of rejecting H naught, right? This is the very first step when H naught is true. When I will reject if S is greater than some critical value, given that let's say mu sigma is sigma naught. Yes or no? Now tell me how will you proceed? Okay, in G test, what was our next step after this? In case of Z test. After this, what was our first step?
We need to find out the value of alpha.
Yeah. When we
Probability
are
of
proceeding alpha, after writing this, what was our first step?
probability of rejecting H naught and given
Yes, not. This is I have written. I have written
uh-huh.
reject. I will
Yeah, yeah.
reject. That's okay. After this, what was the my first step? In suppose in Z test, what was the first
We
step?
need to Z is equal to X minus, just like that equation we
I mean,
write.
basically, we had to convert in Z form, right? So
Yes,
for
sir.
this, we have to convert in chi-square form because we are testing the for variance, right? What is the chi-square? It should be n minus 1 s square divided by sigma square, right? So what is this? So can I do n minus 1 s square, right? If you do, okay, this is okay. Before going to that, if now can I say alpha is same as probability of s square greater than c square given that sigma is equal to sigma naught, right? So to convert in chi-square form, what is the things? We have to divide multiplied by n minus 1 s square divided by sigma square, right? This is something we have to do. See, into converting Z form, I mean standard normal, what we are doing, we are subtracting the expected value divided by standard deviation, right? Here to convert in chi-square, we have to keep in the this form. Now this will be greater than n minus 1 c square divided by sigma square, given that sigma equal to sigma naught, right? Now it will be alpha equal to probability. Now what about this? We have to use this sigma naught value. So it will be n minus 1 s square divided by sigma naught square. This will be given to us, and n minus 1 c square divided by sigma naught square. Okay. So it will be alpha equal to what about this? Okay, what about this? This quantity is nothing but chi square n minus 1 greater than n minus 1 c square divided by sigma naught square. Basically, after solving this whole thing, I can find out the value of c. Okay, basically we have to do alpha equal to 1 minus probability chi square n minus 1 lesser equal to n minus 1 times c square divided by sigma naught square. Okay. So the same approach, it will be 1 minus f, I mean CDF of chi square n minus 1, n minus 1 c square divided by sigma naught square. So after solving, I mean after putting the alpha at 0.05, we will find the value of c and the sample variance, and we will compare whether it's greater or less. Accordingly, we will take the decision about rejection or acceptance of the hypothesis. Are you getting? So is this clear to everyone till this point?
Yes, sir.
Okay, means you are getting to, key thing is we have to identify first of all whether we have to test for mean or whether we have to test for the variance. Okay, accordingly we have to convert in the form, I mean the form of sorry, in the form of if its variance is known to us, I will convert in Z test. If its variance is unknown to us, I will convert in T test. If I'm talking about variance to test the sigma is equal to sigma naught or sigma is greater than sigma naught, something like that, then I will convert into the chi-square test. Is this clear so far? Any doubt?
Yes, sir.
Any doubt till this point?
No, sir.
Okay, so there is one different scenario. I mean, so far we have discussed about to test the mean for single sample, to test for the variance for the single sample. What about if you will have two samples, then how will you proceed? Yes or no? That might be a question, right? How will you check if you have two different samples then?
Use F test.
Sorry?
Then we use F test.
No. Okay. F test is for C. F test is for to test the variability actually. Okay, to test for the mean. See, to test for the mean, we have two tests. First one is Z test. I will use Z test if variance is known to us. I will use T test if variance is unknown to us. For to check the variability, I mean sigma is equal to sigma naught or sigma is greater than sigma naught something. I will prefer the chi-square test for single test, right? If you will have two different sample, for it was for single sample. If you have two different sample, right, then in both sample, if variance is known to us, right, process is same. If variance is known, then what we were using in case of single sample, we use Z test, right? If variance is known to us, again we will be using the G test. Okay, but here it will be difference of mean actually. Okay, I mean rather than, see, initially we were taking x bar minus mu divided by sigma by root n, right? Now we will define our test modulus of x bar minus y bar. We will take the difference of both samples. Are you getting? Or modulus of y bar minus x bar, anyone? Yes or no? If for the two sample, if variance is unknown to us, then what we will use? We will prefer the T test. Okay, again, then how will you define? You will define, I mean we will be interested to find the difference between these two samples. Are you getting? Basically we will check on an average what is the difference between the mean of the first sample and the mean of the second sample. Okay, basically, okay, how will you define? Okay, my hypothesis will be something like that. H naught I will define mean of the first sample is same as second sample, means there is no significant difference between the means of the two samples. And alternative, accordingly we will define, I mean as per the question, whether it will be not equal to, or whether I'm going to consider greater than, or I'm going to consider less than. I mean it will depend how we are I mean what kind of our claim is there. But my null hypothesis will be there is no significant difference between the means of the two samples. Are you getting? Initially for single sample we are saying mu is something mu naught per particular value, any particular value. Mu is greater than something mu naught, and mu is less than mu naught. But in case of two sample, we will assume, I mean we will define our null hypothesis. I mean mean of the both sample is same. Is this clear? Are you getting this
Yes,
idea?
sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So, but the only key thing is you have to observe variance is known to us or unknown to you. Okay. Accordingly, you will proceed. Okay. So let me define some G test, and after that we'll see. Okay. There is F test. Okay. We'll see. We'll see. Otherwise, if there is any test left out, we will discuss in the next session. No problem. So for two sample tests, suppose I have x1, x2 up to xn1. These all are IID, okay, normally distributed, okay, with mean mu1 and variance sigma 1 square, okay. And another sample is, let's say I have y1, y2 up to yn2. These all are IID normal distributed, okay, with, let's say, mean mu2, this is mu1, and sigma 2 square. One thing you can you have to notice, these two samples should be independent, okay. Now, so tell me, what about distribution of x bar? What will be the distribution of x bar? It will be normal. And what will be the parameters?
Mu comma sigma 1 square by n1.
Yeah, mu1 comma sigma 1 square divided by n1, and distribution of y bar will be
mu2
comma sigma 2 square divided by n2, right? Now, tell me, see, we have to check the difference of these two, right? What is the distribution of x bar minus y bar? Basically, we have to find the expected value of x bar minus y bar. It will be
mu1 minus mu2.
correct. And variance?
Add it.
Sigma 1 square divided by n1 plus sigma 2 square divided by n2. Now, just observe the things. For the single sample, we had x bar follows normal mu comma sigma square by n, right? If variance was known to us, I will prefer the G test, right? And for G test, what we are doing? We were doing x bar minus mu divided by sigma by root n, right? If sigma is unknown, then what we had done? We were moving to the T test, x bar minus mu divided by s by root n. This is something T n minus 1. Yes or no? This is something I can do same here. Yes or no? I know the x bar minus y bar distribution normally mu1 comma mu. If variances are known to us, something like that, okay, then I will prefer G test, and similarly unknown to us, then I will subtract this mean and I will divide by the this standard deviation. Yes or no? Are you getting?
Yes, sir.
Yes, sir.
Okay. Now.
Hello, sir. Sorry.
Yes.
But what happen if the distribution is not normal?
Yeah, then basic distribution is not normal. If you have large samples, I can simply convert in a standard normal, right?
Okay, by using Z.
Okay.
So by after conversion, it make 0,1.
Yes, you have to convert in 0,1.
Okay.
Okay. So for single sample, what we had done, we know n minus 1 s square divided by sigma square is what? Chi square with n minus 1, right? Yes or no? This is something we had done for single sample, right? Now you have two different sample, so I can simply say, I mean, you have samples x1, h2 up to xn1, right? And y1, y2 up to yn1, sorry, n2. Then can I say for this sample, n1 minus 1 into sx square, I mean, this is for sample very first sample, divide by sigma 1 square, it will is chi square distributed n1 minus 1, can I say? And n2 minus 1 into sy square divided by sigma 2 square, this will follow chi square with n2 with a degree of freedom n2 minus 1. Yes or no? Are you getting?
Yes, sir.
So far clear? Okay. So I will give you some idea of F test. So there is one concept, ratio of chi-square variable, right? Two chi-square variates here we have. If I will divide by, let's say I'm saying x1 is, I'm just treating, let's say x1 is chi-square distributed with n parameter, I mean degree of freedom n1, and h2 is chi-square follows chi-square distribution with n2 degree of freedom. Then ratio of x1 divided by n1 divided by x2 divided by n2, it follows f distribution with parameter n1 comma n2. I mean, see why why we are moving to f distribution? Because if you will be having two samples, right, and you want to test the variability for those samples, then I will prefer the f test. Okay. I will prefer the F test. F test is nothing but the basically at the end we will get the ratio of the variances. I will come to that point how we are getting. Okay, so this idea is okay. This is the one concept you can keep in your mind. I mean, if I have one variable which is follows chi-square distribution with and 1 degree of freedom, chi-square distribution and 2 degree of freedom, then ratio of x1 divided by n1. So this n1 is nothing but degree of freedom, and this n2 is nothing but degree of freedom. Then it will follow f distribution with n1 comma n2. Now if you see, this parameter is what? Chi-square, and this is again chi-square, right? You can treat this as a x2 and this is as a x1. If I will divide this by n1 minus 1 with respect to parameter degree of freedom, okay, basically what I'm trying to say, if I will divide like n1 minus 1, okay, sx square divided by sigma 1 square, right? This was the chi-square, divide by n1 minus 1, right? Divide by whole division n2 minus 1 sy square divided by sigma 2 square whole divided by n2 minus 1, right? And this will follow f what? n1 minus 1 comma n2 minus 1. This will be your n1 minus 1 degree of freedom comma n2 minus 1 degree of freedom. Is this clear so far? Yes or no? Are you getting this or any difficulty?
Kind of, sir.
Okay, very okay. Okay, so far this one is clear. I mean, this is one concept actually. Okay, ratio of chi-square variance divided by I mean respective degree of freedom is nothing but f distribution. It's called f distribution with parameter n1 and n2 degree of freedom. Okay, so here if you see, this one is what? This one is chi-square with n1 minus 1, right? If you see, if you compare this one and this one, what there is some similarity, right? Yes or no? So this n2 minus 1 sy square divided by sigma 2 square, you can treat as a x2, a single variate, and here it's a n2 degree of freedom. Here, and if you see n2 minus 1 degree of freedom, I mean, instead of n2, I have n2 minus 1. Instead of n1, I have n1 minus 1, right? So if I will divide with respect to degree of freedom, x1 divided by n1, so this is your one of the chi-square, right? n1 minus 1, and this is the n1 minus 1 division of the respective degree of freedom. Same here, chi-square n2 minus 1 and divide by respective degree of freedom. So we'll get f distribution. Now this n1 minus 1 and n1 minus 1 will get cancel out. n2 minus 1 n2 minus 1 will get cancel out. Yes or no? So we will having sx square divided by sigma 1 square divided by sy square divided by sigma 2 square. Okay, so this is nothing but f n1 minus 1 and 2 minus 1. Okay, some sort of idea you are getting somehow. I mean, some sort. If it's not getting fully, you can just go through it again. Okay, so basically, okay, in mean, to test the mean, what how we defined our null hypothesis? We defined mu1 is equal to mu2, right? To test the variability, how will you define? I can define my null hypothesis sigma 1 square sigma 1 is equal to sigma 2. I mean, I will assume there is no variability, I mean, in both data set. Or I will say, I mean, basically I'm trying to say variances are same for both samples, right?
Yes, sir.
Okay, so if you see under this null hypothesis, under H0, if both are same, so Sx square divided by sigma square divided by S square divided by sigma square, both will be same, right? So here sigma square will get cancel out under this null hypothesis. So at the end we will get Sx square divided by Sy square, it is following f n1 minus 1 comma n2 minus 1. So this is called f distribution. I mean, when we are interested to know the, I mean, to test for the variability for the two samples. Okay, is this clear? Some rough idea is okay. Are you getting? So basically, whenever you will have a single sample, okay, when I had single samples, if suppose I'm saying x1, x2, xn are something IID x, right? With let's say it's following normal mu comma sigma square. If sigma square is known, then what we are using? We are going to use the J test, right? For mean. I mean, my null hypothesis was mu is equal to mu naught, and alternative was mu is greater than mu naught. I mean, I can define. If sigma square is unknown, then I will use the T test, right? Yes or no? Then it T will be, how will you define? X bar minus mu divided by S by root n. It is following T n minus 1. If I have to use for the variance, so sigma is equal to sigma naught against alternative sigma is greater than sigma naught, something like that. Okay, then I will be using the chi square, which is n minus 1 s square divided by sigma square follows chi square with n minus 1 degree of freedom, right? So these were the three main tests, right? And in case of two sample test, now you will tell me two samples. For two samples, if I have to test for the means, right? For difference of means, okay? So what I add? X bar minus y bar follows normal mu1 minus mu2, comma sigma 1 square divided by n1 plus sigma 2 square divided by n2. So this is something I can use the G test when variance is known to us, right? And I will prefer T test if variance is unknown. And what is the hypothesis? It will be mu1 equal to mu2, and alternative is nothing but mu1 is greater than mu2 or mu1 is less than mu2, something like that. Okay. And to test the variability, okay, to test the variability, what is the test? This is called the F test, right? So for to test to check the variance in single sample, we had chi square, and in the two samples we will be having F test, and which is nothing but I can find out, I can define something h naught as sigma equal to sigma naught and alternative accordingly. And then my F test will be as simple variance of first sample divided by simple variance second sample, and it will follow F with parameter n1 comma 1, I mean with degree of freedom n2 comma n1 comma n1 minus 1 comma n2 minus 1. Okay, so these were the main test for different kind of scenario. Okay. Okay, so all these are clear.
Yes, sir.
Okay, so we'll see the problems related to this in the upcoming session. Okay, so some sort of idea about test is clear. In which scenario you have to use which test and all.
Yes, sir.
Okay, one more
Yes,
thing.
sir.
There is a ratio, right? Sx square divided by sy square. Tell me, just kind of you can take as a homework. Why we took the ratio? Why not difference of the sample variances? Okay, just you can consider as a homework. Okay, okay then
Yes.
we'll meet in the next session. Okay. Is there anything else?
No, sir.
No, sir.
Thank you.
Okay, fine, fine. Is there any session after 8?
What, sir? Didn't.
Okay. Okay, then
Because of hello sir,
yes.
just say we're taking the ratio for removing the unit. I think
No, anything else?
no, because f is a number, so I think it is for removing the unit.
Yeah, unit might be a reason. Why we are taking the ratio? Why not difference? Because in case of mean, we were taking the difference of sample means, right?
Yeah.
But why not? Why not in? Why not? We are taking the difference. Just think.
Don't know.
There is a very simple concept. Okay.
Okay.
If you take the difference, then what can be the scenario? Okay. Just think. Just think. Okay. Okay. Then we can. Okay. I mean, I can tell you the answer right now, but why I'm I mean, like giving you, just think a little bit. Okay. Because there is some property related to variances, right? Something variance can't be negative or something like that. This is just a hint. Just you can think more on it. Okay.
Okay, sir.
Okay.
Okay then. Thanks everyone. Is there anything else? Everything is fine.
Yes,
Yes, sir.
just one.
Yes. Yeah,
There
yeah.
is additional content in week 9 and week 10. No? So are those important for the end term
No,
questions
no.
will be there?
Additional content, it's important for your yesterday. I mean, if you want to do, then just explore. There will not be any question in end-term exam related to additional content. Okay, but those are
Yes, sir.
those. If you are going through those topics, it will be very helpful for your further yesterday and all. Okay.
Next subjects. It will be useful for the other subjects.
Correct.
But
Correct.
today,
Correct. Yeah, actually, initially it was in term, but now we are not including in term because content was very hectic. So there will not be any question related to additional content, but it's a very, I mean, you can say important kind of thing if you are using the practical scenario, if you are going for the practical scenario. Okay, like
And
confidence
sir,
interval and all. So confidence
yes.
interval is very, very important. If you are in real life scenario, if you are going to make any statement, any conclusion, rather than saying any statement with we can't say anything with certainty, right? Like you are 100% sure. So confidence interval is very helpful. Like you can say I'm 95% sure about this statement, and 90% and 99% sure about this statement. So you can go through that, okay? Because in real life scenario there will be I mean there will always be some margin of error if you are performing the things, okay?
Yes.
Yes, sir.
and
uh,
sir, when the quiz to result are upload
within
come.
1 or 2 days they will I think they should uh, 2 or 3 day maximum. I don't think it will take more than that time.
Okay, okay.
Okay, yeah. Okay then, thanks everyone. Bye.
Yes.
Thank you, sir.